Hello, my name's Elliot Cohen. Today I'm going to be teaching you the 2015 FRQ number 2. Now in number 2 they give you a graph that shows R and S. They also give you some information. The information says let f and g be the functions defined by f of x is equal to 1 plus x plus e to the x squared minus 2x, and g of x equals x to the fourth minus 6.5x squared plus 6x plus 2. The first step that you're going to want to take in this equation is graphing the two functions in your calculator. Make sure that you don't miscalculate the functions into your calculator, because that could really just mess up your entire problem. You want to double check that the graph that's given on the problem and the graph in your calculator match identically. Now for part A, the first thing you're going to want to do is find the point of inflection. That'd be this point right here, right in between R and S. So it's basically when f of x is equal to g of x. The way that you do that in your calculator is you use the scroll button, and you get as close as you can to that, and then find the point of intersection by and once you click that, you click enter twice, and you should get your point of intersection, which is 1.0328319. This is a very important number, and it's a very important number, so you're going to want to store it. In my calculator, I stored it as A. You can store it as whatever number you want, but this will help you later on in the problem. Here are some other tricks for this problem in terms of your calculator. First, you're going to want to store your two equations. What I did is I stored my first equation as y1 and my second equation as y2. And by doing this, you can get through the problem quicker and save some time for later problems. Also, it says here that A is stored as 1.0328319, which is your intersection, which is a very important number. Now, after that, you're going to want to set up the integral, because so the integral from 0 to a, which is from here to here, because you're trying to find the area, is g of x minus f of x dx. So that's the upper equation minus the lower equation within the summation of the integral, plus the other side on the right hand side of the point of intersection, which is integral from a to x, or a to 2 f of x minus g of x, upper minus lower on that side, dx, of course. So when you plug each side into your calculator, you get for the left hand side of the point of intersection, you get 0.9974, and the right side you get 1.0069. You add those together, you get 2.004. A very important point that a very important trick that I use when I solve these problems is I calculate both integrals differently, because plugging so much information at once could lead to a little error, which could mess up the entire answer. So I do the left hand side, and then that's why it's this number, and then I do the right hand side and get this number, and then add them together to get this number, so that it gives me more time just to focus on the left and the right. So that's part A. Part B, the first thing you're going to want to do is, in order to find the side of the cross section that's given, you're basically looking for f of x minus g of x. Also, using that, you're trying to find the area, so that's f of x minus g of x, which is just a side of the cross section, squared. That'll give you the area of the cross section. Now, using this, you can then go into your volume equation, which is the integral from a to 2 of f of x minus g of x squared, which is your area of the cross section, dx. When you plug this integral into your equation, I'm sorry, it's from a to 2 because you're just looking for s. You're only looking at the s component. When you plug this integral into your equation, you get v equals 1.283. And that's an exact answer. Moving on to part C. And also, when you start off the problem, you're going to want to know that the area between the curves is the integral from a to b of the absolute value of f of x minus g of x dx, and then also the volume, which we just used in part b, is the integral from a to b, which was for s a to 2, of the area x dx. These are just equations that you're going to have to know for the AP exam. Part C. So part C. Sorry about that. To find the vertical distance, that's up and down, you're going to want to set up h of x, which is what they gave you. And h of x is really just f of x minus g of x, which is a difference. Then they want you to find the rate at which h of x changes. Now that would just be h prime, and it changes at 1.8. So that's h of h prime at 1.8, as you can see right here, is equal to, and then it's the difference equation, which is the derivative of f prime at 1.8 minus the derivative of g at 1.8. This you can just solve right into your calculator using y1 and y2, and the derivative of y1, derivative of y2 at 1.8, and you get h prime, which is the rate at which h of x changes at 1.8, is negative 3.812. So that means it's in a decreasing motion at 3.812. I hope you got a lot out of this video, and this is more information than just the scoring guide. Thank you.